Welcome
Yeah.
everybody. December 9th, our holiday special.
Yeah. Oh, and let's see real quick. Someone's saying that, yes, I know I'm dark on the left. We were actually talking about that. I need to
That's
get
his that's his soul, guys. That's his
I
soul.
need to get some light on the left. But yeah, look what's back,
Yeah.
everybody.
Turn
Look
turn your
what's
flashlight
back.
on your iPhone and put it on your left
Mhm.
side.
There we go. We have the Christmas tree for the show. Look what I did, Curtis.
Yeah. Oh yeah. Thanks. Yeah.
Okay.
Well, everything I'm going to do is going to be following up. Okay, so let's kind of go through some quick notes. What was there a recent update? I forget, or was that last month that we actually had?
Last month was an update. I did notice that there is an update on the Central Station 2. It looks like it's just icons, no version update, but it took me about a half hour to do it last night for the Central Station to do the whole update. So it's just good to keep current is all. No big deal.
Do you have those version numbers handy? Do you know?
Not handy. They haven't changed since last month.
Okay. The newsletter, the digital newsletter, has gotten released. What today?
I think it
This
was
morning
just
or
this
last
morning.
night?
Yeah.
So if you need to track that, that's available for those who are club members. If you're not, please sign up. You should all be club members to get into this. Um, Anyways, today's topic, or do we have any kind of comments before we get into today's topics that you got? Anything you want to mention?
No. I think we're well good right now.
Okay.
Nothing new that we know of.
All right. So we'll get right into it then. Today's topic, we are going to be covering event programming. Um, and, this is just the automation features, or, some people may call them macros, give you an event stream. Um, there are a couple types of events that you can do. You can do locomotive events, in which case, if you have a sequence where you want a whistle to go off and turn on the lights of your locomotive, you can. We can also qualify as there are events that you would be sort of track control events. And so we will talk about those as well. So those are generally the two kinds of events we um, sort of engage in, I guess, as users. So to start off, let me just show the screen that we were working, my CS3 screen, so we can begin. Share screen. Okay. Share. All right. So the first thing that we're going to get into, just kind of talk about, and this is our demo display, the first screen that we have. I do have a quick layout here because we will be talking, or I will be mainly talking about track blocking. Again, this is the basic event programming. There's advanced settings, which we will cover next month. But to start off, let me just cover, we're going to go through locomotive programming events. So first off, we're going to click up here at the top with the events button. And we're going to add an event, which clearly you can either go through this button here at the top, edit or add event. Or if you simply just want to add, you just click on the plus here. So to create a locomotive sequence, there are a couple of approaches you can have. And by the way, for screen real estate, if you need to, you see how it gets a little cluttered up here at the top. Let me pull up my annotation window here. If it gets a little cluttered up here at the top, it's kind of hard to see everything. So you can close this window here. Let me go back to the mouse control. You can close that window so you can kind of move this out of the way if you want, or shift it around, give you a little more screen to work with. Now, there is sort of an interesting thing here. Mostly, there's two ways to set up an event. One is the record button, which I think for many people might think, okay, that's the way I need to do it. The other way is the drag and drop method, in which case, for instance, if I want to drag like the light function up here at the top, you can just drag that into this event step bar, and you can see that cursor moving around, and release it, and it places it right in there. You notice that it also placed the locomotive icon in this first step, identifies which locomotive is being controlled. And the next following step is the whatever function you're trying to activate. Now, let me get rid of these, and I can kind of show you a couple of things first. Usually, there's a lot of folks who want to do events that control the speed of the locomotive or control the direction of the locomotive. And here's where there's a little bit of a kludge. You can't really drag a speed adjustment from the control sidebars. That's these two control buttons on the left and right side. It doesn't seem to want to take. However, you can drag a direction control icon here. Okay. If you're trying to make a speed adjustment, I'll clear this out again. And let's just, again, we can't do it from the control bar. You need to actually drag it in from the inventory control. And you can see I'm pulling it up from the bottom here. I'm pulling it up from here. And it now gives me a 0 figure because frankly, there's no speed adjustment right now on this. And just sort of, let's kind of do something here as a test. If I have a speed adjustment already, let's say I've been running the locomotive at 36, I can drag it up and it will place that speed adjustment in there for you. So I wanted to get that out of the way because it's a weird kludge with locomotive programming speeds. You can't drag it in from the left or right side. You're going to have to drag it in from the bottom here. Now, so far I've been just talking about dragging. Well, actually, before I get into that, let's kind of go into like steps. So this is just a simple step of event programming. And then what you can do is, let's say you want to have the light come on, you drag that in. We'll talk about the sound events in a minute, but there are settings that you can do on this. And to change values, for instance, let's say you don't want the speed at 36. Well, you click on this while you're in edit mode. You will click on the speed setting here, the icon representation, and then you can change the value of the speed to whatever you want to adjust it to. That's one issue. The other thing is when you have something like a light function that has an on-off function, you want to do the same thing. You will click on this, and rather than the function, and I believe you can change the function if you want to switch functions by clicking on that function button. It's weird. That's this one here. You can change the function type if you wanted, or you need to change it so that the light turns off instead of on. You click on the value and it gives you a list of the options that you have. So it's either going to be a light off or light on function. We will get to this delay part in the next session here. So that's sort of how you set these events. And how everything works is it's basically going to work in the sequence from left to right. The default setting for all events is going to be manual mode. That means that when you have an event and it's closed off like this, and let's go back to our event window, you have this display here on the left, and let me just kind of circle it really quickly in case you're not clear. You have this display here. By clicking on this side of the display, it plays the function as you to test it. If you click on the down arrow, it opens up. Sorry, I didn't do that because I'm actually on video mode. If you click on this down arrow here, it will actually open it up and you can edit the function. So going back to it, so what I've been displaying here is basically a drag and drop method of doing event programming. Oh, sorry, backtrack here a little bit. This hand up here at the upper left corner, that means it's a manual mode function. So essentially what happens is, in order for this to do what you program it for, you got to hit the play button and it will play that function. Okay, so sorry for that little sort of going backwards there on you. The edit method that we've been doing is the drag and drop method. And let me open this back up again here. And let's kind of start over. And the drag and drop method is generally what I recommend. Occasionally, you do want to use the recording method. But I'm going to show you why I have that preference. So let me close this back out window. Let's say you kind of want to pre-plan your sequence, okay? And if you're going to use a recording mode, and there's a good reason for it, because if you don't have a pre-plan, you're going to create unnecessary delays. So let me show you what I mean. Let's say we're starting from scratch. We have a locomotive that's 0. Obviously, we'll do a sequence like this. We want the lights to come on first, then we want the locomotive to start. So once you hit the recording button, it's live recording at that point. So picture this. If I had more than, just the one locomotive in this bottom screen, I'd also have to locate that locomotive. So I'm going to hit record, and it's not going to really work in that sense because I only have one locomotive, but watch what happens. I'll click record. Starting in recording mode, I'm going to drag my locomotive up. Okay, and maybe it won't take. So let's see. Let's do it this way. This one is a live recording. Now it sets the speed for the locomotive 25. And I did this out of order from what I said the previous one, which is a good thing. So now I want to drag the light function, or you just don't have to drag on it. You just have to click on the function. Okay, so let's turn the light off, and it adds step by step. Same thing will apply for the sounds. Okay, so let's stop the recording now. And I'll explain why I don't like to use the record function that often is because for each of these steps, this is just the locomotive icon. We're going to go into the edit view for each of these icons. And now we'll go into the speed adjustment. Each of these steps, because I was in record mode, creates a delay. It creates, so this one here created close to a 12-second delay. The way the delay works is after every adjustment here, based on the left, it now starts a countdown. So it's going to be 12 seconds before the next step in the event occurs. So now I'm going to click on the light function. And the light is now going to turn on, and then it's going to initiate a 6-second delay before it goes to the next light. So the next step, there's going to be 6-second delay. So the problem here is that a lot of users, if you have like a lot of locomotives or you don't really know where the function is and you have to hunt around for it, it's always going to be counting down and adding those delays to it. And while that might be desirable, the problem is if you want to change it, well, you're going to have to go through each of these steps and edit the delay on it if you don't want a delay. And you're going to have to go through each of these steps to eliminate that delay. Okay, and this was the last step just before I close it. So there's none. Okay, so let me just kind of clear this out. Let's close that out. Whoops, wrong window. So let me actually just delete this function because we're going to start over here. The alternative, again, is to use the drag and drop method. And I can just add the locomotive down here, speed step 29. I can add the light. Let's actually have the light turn on. So you set the value. And then, I can have the whistle go on. And right now it's on. Turn it on. And you can see right now, none of my steps have a timing delay on it. They're just going to go bang, 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 one after the other. And you can now add delays after the value changes to whatever the setting is. Then it will add the delay and occur before the next step in your sequence occurs. So let's say I want this to be on for 5 seconds or 6 seconds, as I wrote in here. And then now you have a 6-second delay after this occurs and before this occurs. So that basically sums up why I'd rather use a drag and drop and why I recommend it. It's cleaner when you want to edit stuff out. Now, I did say initially that I want the light to go on first before the speed ramps up. Once you have these steps in there, if you do want to adjust these steps, what you can do is you can hold it down and you should be able to, you see how you have that blue cursor marker. You just want to drag that around to wherever location you want that to occur. Okay, so you can now change the sequence of events around to according to what you want. And again, you do want to be aware of any kind of delays that maybe you've incurred, because now you're going to have the light that's going to go on. It's going to wait 6 seconds before it actually changes the speed of the locomotive to 29.
And one note you did there, you have the horn going off, but you don't have a function to turn the horn off.
Exactly. So let me get to that. And okay, well, let's address it now. Sound functions are really kind of tricky. You have something like a whistle is what we call it. It's a looped sound. They have a sound recording. What it does is, as long as the function is on, it just kind of loops back on itself, so it sounds like one continuous whistle. Now, when I would imagine when you're playing with your locomotives, and you do notice that some are programmed to have a short whistle and a long whistle. Those timing durations are set within the programming of the decoder. Those timing durations do not apply when you're doing events. Okay, so what's going to happen here is, let's say this was a short whistle, and when you press it once, it only goes for like a second and then it turns off. Okay, that's partially the setup in the CS3, where the function button itself is set for like a momentary. It's also like when you have those whistles that only sound as long as you have your button on the icon. And then when you release it, the sound function goes off. Those momentary and types of functions do not apply in events. So what that means is, when you program a whistle to turn on, you also have to program the whistle to turn off. Okay. And that also means that when you turn on a function like that, you may need to have a delay. Let's say you want a short whistle that's like a second long. You would program the second, and you can also program it for these durations, milliseconds or minutes. If you're really tolerant of a lot of noise, then set everything for minutes. But personally, I don't do that. So what that means is you're turning the whistle on for 1 second, and then this will actually shut the whistle off. Now, you're also going to run into issues like, let's say you have a station announcement that a lot of the MFX locomotives have. The station announcements have a longer program duration. You could have one that's like 20 seconds long. If you do not set this, so let's say that this function here was a station announcement. And when you open this, let's see, when you open this and you only set the delay for like 2 seconds, but it's a 30-second soundbite, it's going to cut that off. So when you have something like a station announcement, you might want to like time the duration, see how long it is, so you can program an appropriate delay for that to go on.
Well, there's one thing I noticed also when you get a chance.
Yeah, there's also something that you can realize, that this timing delay, I believe, is not affected by other functions. So in other words, if I actually had a function in between this, and this, I think we might have to revisit and test. The thing is, if I had this set for 45 seconds, right? Let's just say, well, it's a 40 second. Let's say it's got a 40-second delay. Well, not a 4. Let's actually make it shorter just for the example purpose. Let's set a 5-second delay. So I have this sound function that's on for 5 seconds. And if I play this, the question is it going to run for the full 5 seconds before the light turns on, before it kills the sound? So there's this weird sort of gray area that I haven't tested, because I usually don't do a lot of event sequence programming in this fashion.
Yeah. The
One,
other problem is if you have an on of a whistle and then an off right after it without a delay, it sometimes doesn't have time to play it and you don't hear anything.
exactly. You're not going to know. You're going to think, well, it's not taking, and that's exactly the cause.
And the sensor station doesn't realize the difference between a short whistle and a long whistle when you select it from your icons list. So even if it's a short whistle, you still have to program a stop sound. And if there's no delay in the initiate sound, you may not hear it. It may just be so quick because the processor runs through the event so quickly.
Okay, I did have one question. The delay comes after the event that the delay is assigned to. So, in other words, I set the delay for the sound here, and it's going to count 5 seconds after it turns a whistle on before it actually gets to the next event. But sounds are tricky, and it's kind of worth playing with. So right now what I did was I saved this. There's a 5-second delay on the whistle, and we can maybe count it out here. So I'm going to activate this event. This red icon should actually go in sequence, if I remember correctly. I should not be in stop mode when testing this. So let's try this out. Nope. Doesn't want to trigger. It could be because I don't actually have a locomotive on track, but yeah. All right. So hopefully that gives you some information. We're going to get to the meat of the matter, which is actually going to be track programming. I just sort of realized that we needed to talk about locomotive programming, but I think that kind of covers a lot of the caveats that we have to deal with locomotive.
I think you have to hit the play button there in the icon in the blue.
Yeah, but you can see it's hanging up on step 2. That's what this green icon.
It's because you have a delay in there. Hit the down arrow so we can see the event.
Yeah, that's what I was doing. Oh, that's right. You're right. I got to hit this button. So if I click this, you can see how it plays. There's a 5-second delay. Thanks, Rick. And then it turns on the light. So that whole sound timing function, you just kind of have to be aware of those kind of kludges. It's not going to work. It may not work the way you want it to. And sounds are really kind of strict. They have to play the sound. So, if you have a sound function, you might not be able to add any sort of events between that sound function. So just kind of be aware of those functionalities. Okay. Now let's move on to event programming. I want to get rid of this just to make things clear. Oh, also kind of moving on there. You can see up at the top, we have this group button, and this shows all your functions. It's a good idea to separate, especially if you're going to have a lot of events. You might want to create groups on this. So let's go back in edit mode and I'll show you how this is done. So right now, this group button only has an all function. It's going to show all events. But if you have an event here, let's open up the window again. You click on the leftmost icon here, whether it's got the contact number or the manual mode button, and you open up the edit window, and you can see at the bottom I have a group setting. So if you want to create a new one, you click on the again button, and you can, you just give it your name. So we'll just call it let's say it's your first Loc 1 events. Okay, we'll just call it Loc 1. We just know it's Loc 1. Okay, and you just go ahead and click OK. And if I close this, now I can actually go to Loc 1 events and just view those. Okay, so without deleting this, we'll just kind of move into the next thing, and you can kind of see how the grouping is going to work. Okay, so let me minimize this a little bit here. Get rid of our locomotive controls because we really don't need that at this point. Close this really quickly, and let's minimize that. So this is the layout that we're going to use. Initially, a lot of users or new users, they're going to use what we call circuit tracks. And those are those C tracks with the little flippers that the sliders make contact with. So we're going to start our first bases here. What I am going to show you to do is how to sort of create block programming, which is essentially each section of line that's between these signals here. And so would be considered a block. And the definition for a block is basically any area where you can basically only have one locomotive in occupancy at a time. So I have 4 blocks that I've generated on this layout. And the concept here that we want to accomplish is that, whoops, any locomotive that passes a signal light is going to be occupying that line, and we need to stop any locomotive behind it from entering into that block. So for instance, if I had block 1 here, let's say I have a locomotive right here. This is my locomotive. It's traveling onto this block here. And once this block is being occupied by a locomotive, obviously you want to keep any locomotive behind it from entering, in which case we have to set that light to green, red. So, right? So think of it this way. We now have a locomotive on this curve. Sorry, guys. And we release this locomotive, and it's green. And this, once it enters this block, it's vacating the block behind it, right? So it's entering into this block, but it's vacating, whoops, it's vacating this one, right? Once it enters into that block, this signal light will go red. Okay. Now that this block is clear, this upper block, clear that again. And let's draw there. Once this block is clear, yeah, white's a bad color, Curtis. What do you think about that? Now that I have an empty block here, this trigger here is going to release the signal behind it. So now that a trend can now enter the empty block. So we're going to program that, and we're going to discuss a few things, and hopefully everything is going to be clear. So what we'll do is, first we're going to go into edit mode, because I want to place my contacts, which are basically going to be the triggers. They're going to be the things that activate the events. Okay, so wrong window. Let's go into the edit trackboard page. Now, again, circuit tracks operate off of the center ski, the center slider. So the first thing that you maybe want to consider is, where do you place these contact tracks? Okay, so usually what I do is I place these contact tracks after the signal. And you have a first choice. So let's look at a steam locomotive or steam consist. You can have this signal light change colors as soon as the locomotive passes the signal light. And then you'd still have maybe your cargo cars following behind it. The other thing you can do is, let's say you can move it further down the line until the entire locomotive passes the signal light. Okay, and we're using the signal light as your control feature as well. So basically, if you have the signal go red, it's going to stop the train that's following behind it. Okay, so this is kind of up to you. There's no hard rule. You just got to figure out where you want to place it and place it accordingly. So let me actually go ahead and put these in. And I'm going to place them afterwards. Okay, and we're done editing the trackboard page. Now you have 2 states on these circuit tracks. Basically an on and off state. So when they go yellow, it means that they have been activated. And usually these are going to go yellow and back to gray really quickly, because your duration of contact with the slider is very short. Okay, and now what we're going to do is we're going to go into actually creating my event. So let me add my first event step here. And because I'm going to program this for the K1 contact, I'm just going to make sure I know which I'm dealing with. So I'll give it a quick name of K1 so that I know where it is. How I want this to work is, I have, it takes a little bit of visualization here. So essentially this signal light is already going to be green, because I have my locomotive is just passing It's just passing the signal. So this will never be activated if my locomotive is stuck here, right? So this obviously has to be green. So we just start with that premise. The moment the locomotive passes, that means your slider and your power controls are going to be over this contact past the signal light. I can actually now take my signal, and there's two ways to entry. You can either add, let's clear that out so you can see it. I can add my steps here through the article list, which is fine. But if you have a lot of pages and a lot of turnout signals and stuff, it gets cumbersome because then you'd have to know where they are. The recommendation here is you want to create your layout page, because then you have a visual representation of where things are going to occur. So again, I'm making contact with K1 here. So I want my signal to actually go red, because as I mentioned before, this is going to be green so that the locomotive can pass that signal light. Once it passes, then I want to be sure that I'm going to stop a locomotive behind it. The next thing that I want to do is...
You have to add your contact.
Yeah, so that's the other thing. So let's get to that too. So Rick makes a point. This is manual mode. Because we want it to actually read the contacts, I just need to take that icon, and you can see I took this icon and I dragged it onto the left marker here, and now it says K1. And you have two indicators here at this icon here, which I will get to in a minute, so don't really worry about that right now. And let me open up the edit window for this box. You have positions. And for circuit tracks, there's really not a whole lot of choice you have because it goes on and off so quickly. So you just kind of leave that alone. I don't really mess with these functions ever. And as I mentioned before, there's a grouping. So right now what I'm going to do is I only have two options, a local one grouping and an all grouping. So while we're here, I'm actually going to create a new grouping. I'm going to call this blocks. Whoops. I can use the German spelling, or I can use a regular spelling.
Or you can make up your own vocabulary.
Yeah, you can call it whatever you want. So I've now assigned this to blocks. So again, how it works is this contact gets triggered. That's what we call a trigger. And then it creates the event sequences here. So the first thing I want to do is I want to make this signal go red. And that kind of implies that this is going to be clearing this block. And once this block is cleared, I can allow the train behind it to enter into that block. So now I'm going to pull in S4 because that's the trailing train. And you can see now it's going to change that signal to green, which allows this train to proceed. And then eventually it's going to activate K4. So just to kind of show you how that works, and it might be a little quick, so we'll go ahead and close this. You won't be able to test your events when you're in edit mode. So you do kind of have to get out of edit mode so that you're in operational mode. Let me reset the icons. So like now let's look at it this way. I have a train waiting before S1. So my train is waiting here. The first thing that's going to happen is the signal is going to be set to green so that the locomotive now proceeds past the signal light. Once it makes contact, keep an eye on S1 and S4. It's going to be quick. So once this goes yellow, it changes the two icons really quickly. You notice how now it's red here and it's green here. In this instance, we can go, well, it happens so fast. Let's do something for you. And I'm going to go back and re-edit the event. And I'm actually going to create a delay here. So actually let's get into edit mode. I'm going to create a delay. I'll create let's create a 2-second delay. It's always a round figure that I like to use when testing. So, and we'll get out of edit mode. And you don't really need this indicator anymore. Let's turn that off. So now, just so you guys can watch it, the locomotive is green. It's going to pass S1. There's going to be a 2-second delay, and S4 will change to green after this changes red. So watch. The first thing, I'll click on this. This will go to red. 2 seconds. This is going to go to green. Okay. So that's your stream for one block. Now, this is going to be sort of a repeated procedure because now we kind of have to follow along, at least your logic, to the next step. So this is the contact one event that happens. So let's close this out. Go back to my edit mode. And now I'm actually going to do pretty much the identical procedure for K2. So I'm going to add one here. And let me just close this again. So add your trigger, which is going to be K2. You can open it up here and see that the position is on. And the group, now you can see I have a listing for groups. So now I'm going to change that grouping so that it's all part of my block control. And we're going to do the first sequence again here. So S2, I want to drag in, and I want it to change to red, which is correct, because it's sort of a backward stepping thing. So right now, you might ask, well, why is it red again? And I can explain it to you in a second here. And then we're going to actually add that 2-second delay. Be careful. Well, that doesn't matter to you because I'm using this on a PC. Programming on the PC gets a little confusing because it doesn't always take values the way it should. So let's do it here. Add 2-second delay. Add this in here, and you can see it's red, but I want that to be green. Let us know, let us know if I'm going too fast or skipping a step that you're not following.
I can follow along. It's pretty straightforward.
Okay, so that's green.
I can speak for everyone.
Okay, and now we're going to actually do the same thing for K3. Okay, I didn't actually relabel. I did not relabel this event yet. So let me open the add event. Come on, and this should be K2. K2. Now I can close it. Now it's saved. Add K3. K3. Manual mode. Okay. Whoops. I can pre-group it. It doesn't really matter what order you're doing as long as you kind of follow the same sort of precedence. So let me add the contact. Oops, come on. All right, it could be a block in my screen because I'm operating on this window. Open again. K3. There you go. Whoops, wrong way. Let's drag that over here. Delete that. And don't that question mark thing, we can get back to you. That's going to be an advanced feature. Come on. I think I'm dealing with a lag issue because I'm operating through the PC, guys. Okay, so this is green. I need to change that immediate one to red. Add the 2-second delay. Take that. I'm taking the signal that's back and making sure that's my released locomotive. So yeah, it could get a little, it's going to get fuzzy when you're doing this. So you just kind of have to stop and think about, where's my locomotive? What am I trying to do? The locomotive is passing this contact from this signal. So I want to be sure that one's going to stop the train behind it by going to S3. Then I have to go backwards another step for the locomotive behind it, so I can make sure it is going to follow and stop at S3. So the sequences is kind of, you kind of have to retrace your steps sometimes with sequence if you get sort of like lost on where you are. And, it's not uncommon. Even with me, I have to do it, and occasionally errors do occur. So again, we'll set up the final procedure, change the name. this is contact 4. Take the contact, drag it over the manual mode button for automation. And again, pull in my contact. Change that to stop. 2-second delay. Click OK there. And then finally add S3, which needs to be, whoops, too close to the bottom window. Scroll up a little bit. There you go. S3. Okay. So those are your 4 events. And we should be able to get out of events mode. Now, kind of going back to our topic. These are all the events. And as I said, once you group them, I can either just view the loc group, or if I need to focus on the blocks group, then it puts it in there. And you can see that I did not assign K4 yet. So I go back to all, have to go into edit mode, open up K4, and assign that group. So, you know, if people want me to be perfect on these presentations, it's good that I make mistakes, because then you can see how to correct them. So close events. All right. So this is generally how the layout works. And let me just kind of default everything off, turn everything off. In a block operation, so I have 4 blocks, as I talked about. You always have to have an empty block, because you need a locomotive to be able to move into an empty block. Otherwise, train's got nowhere to go, right? You can have less. So I can have this operating on 1 locomotive only. I can have it operating on 2. I can have it operating on 3. So let's say I have 1 locomotive, and it doesn't matter where we start on this. We'll just start with a locomotive here. Okay. And we'll start the cycle. So essentially what's going to happen is we need to manually switch this signal to green to begin the locomotive movement. Once it passes K3, it switches that red to red.
All the signals need to be on green.
Yeah. No, it shouldn't. Okay, looks
like to start it, because S4 is not going to turn to green.
No, the train is starting on S3. So the train that hits this contact changes this to red. S2 needs to go green. And you can see I have an error in the programming for K3. So let me see what the issue is there. K2, S2. And why? Oh, you know what? 2-second delay. Should be whoops, not 22-second delay. That was K3, right? K3, S3, S2. Close. Okay, so there's green now. So what's happening is right now you got a locomotive moving on here. Yeah, you're right. You might actually have a couple of those on green, because if you think about it, my locomotive is on moving on to this, and it's just going to stop at 4.
Yeah, 1 locomotive will work, but it will never stop. You start with all of them on green, and it will just keep going around.
Yeah. So yeah, it's sort of like a priming issue. You need to prime the system first sometimes. And I usually do it with a full line of tracks. So in other words, like I'd have 3 locomotives. If you have 4 blocks, then you want to run with 3 locomotives. Running with less, it might require obviously some adjustment that I just.
Yeah, you need at least 2 to make them start and stop. 1 of them to start and stop.
Yeah. So yeah, thanks, Rick. Presentation time, it gets kind of hard to think about. So let's
turn off the contact on K3.
Okay, so now I have a locomotive going on K2. It's entering into 3. Okay, so this might be kind of hard to follow. Let's actually do the other example where let's say we have 4 locomotives or 3 locomotives, because that might be actually clearer to actually prove the point here. So let's give let's apply some colors here, maybe just to see if that clarifies the issue here. So I'll draw another one. Let's change this to blue loc. I'll put that over here. Okay, let me reset this. Okay, so this is going to be red right now, right? Does this make sense? Okay, so let's make the final locomotive green. Okay, so now drop, drop, draw. Here we go. Now this is your setup. Okay, I guess I shouldn't have moved the. Windows around. There you go. Now this is your setup. You got a locomotive. The green locomotive is now moving because it's green here. It's going to activate this signal. Okay. And let's see, clear my drawings. Now what's going to happen is the green locomotive is now going to travel over here and stop. Okay. This one here was the blue locomotive. And it is now, because it's green, is now going to pass on to this block here and travel this way and stop. But once it passes this contact 2, it's going to stop the train behind it, which, remember, we had the red locomotive up here, which is now going to pass this signal light and enter onto this block. Whoops. Sorry, guys. Just trying to keep track of drawing in the functions of what I'm doing. You have a block that's here, which had activated this contact, stopping this, which now releases the green locomotive. So does that, you guys, can you follow that? It's kind of hard to do a demonstration without actually live tracks running, but essentially you're always going to have like constant movement. So if you see, I have one green light, I always have one locomotive moving, and I can click on that and they're all red, but it released this bottom one. So now that means that this bottom train can move on to this block here on the right. And you can see that all my contacts are yellow. It's because I didn't shut them off. Remember, we're using circuit tracks. That means that they're going to go on and off pretty much immediately. So it's going to look more like this, on and then off. This train can now proceed past this block. Let's clear this drawings out. It's going to go on and off. The train's moving on to this section here. So hopefully that's kind of clear. I got to quit moving the screen around on you. So you can see kind of how
we're getting questions about how does the train stop, basically. And this is basically if you just wire your signals to control track power before the signal itself. And it's just turning the signals to red, which kills the track power for a section of insulated track. You can also use brake modules, but we'll get into that.
Yeah, we're about to get into that next. So that's a good question. You're basically, the signal representation to stop the train is what I can display right now, but physically when you're actually wiring a signal to it, there are wires that you can control to a track that's going to stop the train itself. And those are sort of what I call a unified signal to track control, because when you change the signal, it stops the track. And, it's just one-on-one. So, for display purposes, I only needed the signal light here. So now we're going to move on to sort of, if you get the concept of how the block works, then I can kind of move on to the next section here. But essentially the things that I wanted to kind of point out, when you're using circuit tracks, placement may be important to you, at least as far how far away it is from the signal light. Because if I were to sort of, sorry, I don't need that window. I actually need the trackboard page. If I wanted to sort of have my contacts further on, or at least away from it, and I can do that in 2 sections, it doesn't matter, they don't have to be all 4. The functionality is still the same. It goes off, it changes the light behind it. It goes on, alters the train behind it. So you always have one train moving into the empty block, because remember I tried to say we're going to have 3 trains on a 4-block system. Okay. So now let's go on to reloading our next section, which is we're going to change out from a circuit track now. We're going to actually use contact tracks. So let me restore that plan.
Real quick, to answer Kevin's question about sliders, this is just one form of contact. Probably the simplest form of contact that he's using, a circuit track. You can use contact tracks that can detect occupancy, but that gets into, I don't know, Curtis, are you going to get into contact tracks?
I am now.
You are right now. Okay, contact tracks show occupancy and give you an on and off state that you can program events to. So that's what he's getting into now, Kevin.
Yeah, there was. I was sort of having an internal debate on whether or not I wanted to go over that. We covered. I believe we covered contact tracks and circuit tracks in one of our earlier webinars, webinar 2, probably, if anything. But basically, the difference is you have 3 detection methods on the LED or sensor methods. You have magnetic reed switches, which are specialized sort of reeds, and you have to have magnets on your cars. And then you have circuit tracks, which are the flipper switches, which generally we use primarily before sort of figuring out contact tracks. And those are what the center slider hits. A contact track works by separating, or sorry, I'm sharing the window. Let me unshare really quickly here. A contact track works by insulating one of these outer rails, because when you purchase track, these 2 outer rails are basically connected, and you can separate them one from another. And what it does is when the wheels make contact, it creates a switch to that insulated rail. And I don't want to get into that in detail because it's been covered in a previous webinar in the newsletters. So you can ask a question again and we'll answer it later if you need to. But as far as the webinar goes, I kind of wanted to go through it, skip it as experiences that you should already have. Okay, so anyways, back to sharing the screen. Now what we're going to do here, and this is our basics, we're now going to sort of separate our signals from our stopping tracks. And it's hard to represent what a stopping track is. So by default, or if you were just using signals and you didn't really know, your signals themselves actually have a way to isolate a section of track that kills power to that rail, and it essentially stops the train. But the method that I like to use, or it's kind of cool, it's definitely kind of cool to use, is that we're actually going to use the signal light basically sort of for aesthetics, and then we're going to add either a braking module or stop track. A stop track is generally controlled by using an M84 module. And what that does is it kills power to the center rail when switched on, and that would essentially stop the track. So what I'm getting at is your stop track is independent from the signal aspect light itself. And it's just your choice of how you want to wire it. So when I'm setting up the track, and I'll just place these here. So let's edit the trackboard page. So signal 1 is going to have a sort of a stop track here, a brake module. They have the same purpose as a brake module is a slow down module. It just stops the train gradually, then rather than an abrupt stop that you would have if you're going to use a M84 device. So I place all these in front of the signal. Okay, and now what we're going to do is I'm using contact tracks. Now, just kind of redefine those again. Circuit tracks, again, operate on the center ski. Contact tracks operate on the wheels of your entire locomotive. So the benefit there is using contact tracks is over a reed contact track is like if you had, let's say that this was my circuit track icon in it, right? If it was circuit track in the previous example, I'd have to place it further along if I just want to get the whole locomotive past the signal light. But a contact track is a little bit different because let me place it where it needs to go properly. When you have a locomotive, the moment the front wheels make contact with the contact track, it's going to switch on. And as long as the train, the entire train is on it, and we're talking about AC wheel sets now, because if you throw on a Trix locomotive, you're going to have the insulated wheels and it won't activate the contact track. Once that train goes off, then this contact track will switch off. And that gives you an indicator that the entire locomotive has passed the signal light. Okay, because if we go back to, say, where you use a circuit track, where you're using the center slider, well, the thing is the locomotive can be here, but the rest of your cars may still be behind the locomotive, right? So you got your locomotive here at the front section, but then the rest of your cars are still going to be trailing behind, and they're still going to be in front of the signal light. If you have a contact track, the way that works is the entire locomotive would have needed to pass in order for that to trigger off. Okay, so now let me just go ahead and place these. Now these, when contact tracks in a block situation, I place them pretty much immediately after the signal light. So let's get those. These will actually snap in place and realign themselves. So I'm going to put those here. All right, now we can kind of begin the programming. So contact tracks are great because they have a two-state trigger, which we don't really have when we're using circuit tracks. And that's based on the fact that you have wheel sets that are, that long. As long as this is on, we can create another state. And I don't think that was clear. Sorry about that. We can kind of go over that again. But let's go into the event state and I can show you there. So now we're going to go into event programming. And let's program, let's narrow this window down here. Let's add my first event. The first thing I'm going to do is, again, we're going to add my contact track. That's K1. And let's draw a simple representation of a locomotive here. So that'll be, let's say that's my locomotive. Add another color. And let's say that's my train. Okay. What's going to happen here is the first thing that's going to happen is your contact 1 is now going to be activated. It's going to go yellow. Okay, so that's the position we're detecting for. The moment this contact goes yellow, it's going to activate whatever I program in here. If you think about it, the locomotive is the first thing that's going to pass the signal light, which is actually when we want that signal to go red. Okay. And that's great. So while this train is passing, I'm not going to need to activate this stopping track yet because I still have a train on there. Or let's say you had some weird instance where you actually had another, dang it, draw here. Let's say you actually had the locomotive pushing a train, which, it's not going to happen a lot, but it may happen. If once this brake module or this stopping track goes red, it's just going to kill the locomotive when it gets to this point in the track, right? So that's why we're not going to program anything yet to stop the track. So all I programmed clearly is the aesthetic of the light going green or going red here in this case. And that's my K1 release. Now you see here this icon right here. You notice how it has sort of this sort of bulky plus in front of the locomotive's direction. So that means that when the train makes contact with this contact or goes yellow, we call that an arrival trigger because that's going to set this motion in event. Okay. The next step is now we're going to add a new event, and let's kind of give you my naming convention that I use here. So the thing is, I now have contact 1, so I know which contact I'm dealing with, and I'm using it, as I stated, as an arrival trigger. in short, what it's telling me is this contact will get triggered when a train makes contact with it. It arrives on that piece of track. I'm going to set up now what I call a departure trigger. So let's do, this is going to be now K1. Whoops. This is going to be contact 1. Right. And this is going to actually get activated when the train exit that piece of track. So this is just a labeling first, and just kind of clarify what's going on physically. Dang it, close this window. I'm now going to drag K1 into this as well. But you see, again, my icon has the plus before it. I want it to activate when the train leaves that piece of track, which is departing that piece of track. And you see now the icon changed. The icon is now where the plus, the sensor is following the train. In other words, the train is already past that circuit track. So if you think about it on the layout, what's going on is the train is now fully past this block, right? Because it's gone gray. If you think now, it's actually safe to activate this trigger. Whoops, go away. This is my departure event. Close that. I can now pull this in and set it to stop. Oops, wrong one. Changing the items. There you go. Change that to a stop break. So let's clear these windows out to make it clear. So now you can see that once the train clears, it's going to activate the brake to stop any following train. So let's kind of shorten this, and you can kind of see exactly the sequence of what's going on here. Get out of event mode, edit. All right, activate, change. Oh, I'm in stop mode. There you go. Okay, so we start off with the train on the right side of signal S1. The signal is green, allowing the train to proceed. It's going to make contact with K1. And that's where the locomotive is, right? The first front of the train. It's going to go yellow, and it changes the signal to red. So visually, that's correct, right? It usually goes red the moment the train starts to pass the signal. The brake module hasn't activated, so it allows the full length of the train to proceed past the signal light. Once it passes the signal light, it now will exit. And while this is yellow, you know that the train is on that contact track. Once it passes this contact track, it's going to go gray and then set the brake on, preventing a following train from colliding into the train that just passed S1. So that's the two-step procedures that we use, and that explains arrival and departure triggers that we use, and also why I like to use contact tracks rather than circuit tracks. It's also a little bit of a cleaner look. You don't have those circuit tracks visible. You can still use them in certain instances, like let's say you have a specialized train that you want to, do something. I can't really explain an example right now, but you can use both. There's no reason you can only use one. You can use a mixture of both. I use magnetic reed switches for certain events. Anyways, let's kind of go back into this event. Let's go back into the event. So we're going to go back to our departure event. Okay. And let's close this for clarity. So if you think about it, we've now cleared the block to the right of the signal S1 because I have this indication here that it's stopped. That means that this block is now clear to allow the train to pass K4. So I'm going to drag, I'm actually going to pull in at signal S4. And as you can see, it already changed to green, which is exactly what I want it to do. So this control trigger actually affects, like it did on the previous example, the signal behind it, allowing a train to proceed. And because we probably also have a block to it, because by default, we also want to make sure that we set release power to the track. Because remember, my signals and my stopping blocks are independent now. They're not the same thing. So when the light goes red or green, it's not going to stop the train or control it in any way. So I have to set the 3 steps. If you want to have any kind of delays in there, you can add those. Go ahead. You had a question?
Well, we didn't actually explain how we do that, because if a user does connect the brake module to the signal, it will be instantaneous. We separate them.
Yeah. So, I mean, just to clarify, it's sort of like asking what gets the train to stop. You can purchase your signal lights that have wires directly that control the track, but they work in unison. So when the light goes red, it kills power to the track, that section of track. When it goes green, it does that. What we do is we don't use those wires on the signal light, and we use a separate module. So it's like a different decoder that you're using to control track power.
It's a M83.
No, no, M84 to control track power.
Well,
or if you're using a brake module or a slowdown module, then you use an M83. So if that's what you're referring to.
Yes.
So a little bit of caveat, you probably want to send us a question on that one. That's all fine. So let's kind of close the event. Now you can actually see how the whole procedure works. Again, just using the one example. So this is going to be, this is our state. We're holding a train off by B4. We're releasing the train, and you can do this in a sequence. So usually when you release a train, you want to have the light go green first before you release the brake module or the stop module. When you're stopping trains, if you think of it this way, if you're stopping trains and you set the signal light to go red first, it's not going to stop the train until you hit the brake module and stop the train first. So what I do is when you want to stop a train, set the stopping block or the brake module first, then set the signal light afterwards. So there's a sequence of order. Stopping a train, use the brake module to stop the track, and then set the signal. When letting a train go, set the signal first, and then set the train to release from the brake module. So again, the example that I'm showing here is we're going to release the train here at signal 1 and release the brake. So now we have a train that's proceeding on to K1, contact 1. And then you want to just watch what's happening here. It's going to first set these to red, if I did it correctly. I might be missing a step here in hindsight. So this activates it? No, that's right. I did it right. So that's going to set the signal to red because it's a different event. Then when this clears, this is going to go red. This is going to go green. And that's another order of events. You can release these trains on the right first. In other words, if you set your sequence events to release this first and then set this secondly, then, it's just like you have space, it's okay. But, generally what I usually end up doing is make sure I stop the track first and then set this sequence of events second. So your order is going to be kind of, important to a degree. It's just up to you and how you want to proceed. So now back to the actual operation. The train leaves contact 1. This goes red, and it switches the next train behind it to proceed onto the empty block. And as we said, so let's kind of repeat the procedure. This procedure is going to be practically the same as the first 2 steps. So just to show you, I have my arrival trigger and I have my departure trigger, and this is what they look like. So that's the arrival. That's the departure trigger. And I will mimic that now using K4 as my contact. So I'm kind of going backwards from the first example. It's just I've gotten used to how it needs to be done in the order, and it just doesn't matter which order you do it on. You just need to recognize what you're doing. So there's my arrival trigger for K4. Move this out of the way. I always get windows. When you're doing this, windows will get in your way, and you're going to shift them around a lot. So basically, essentially, when this K4 goes yellow, which is my arrival contact, I want to set signal 4 to red. Open it up, change the signal to red. And that's pretty much it for the arrival contact. Whoops. Open the event window again, create a new one. Blank that out. This is K4 departure. Okay, so my grammar, it's not perfectly identical, doesn't matter. And remember, we're going to change this positioning now so it's a departure trigger, not an arrival trigger. The reason why we didn't have this with circuit tracks is because it's so fast that it does a departure and arrival at the same time, which is sort of a disadvantage because this allows us to actually separate the timing into two different events. So this is now going to be red. And we're controlling.
Also, if you change the state on the on your track diagram, it'll to what you want, it'll put it in your event correctly. You don't have to go and edit the state.
Yeah, you can do it this way before you drag it, but I just did it backwards, didn't I? So let's delete it. So that's actually releasing that. I can drag it. Sometimes I hold it down too long and it changes on me, so I end up having to edit anyways. You can actually see, and then we just kind of notice this. Like if I hold this down too long, I think it was opening up some weird window for me. I think it's actually doing some behavior that I haven't explored before. So I might have to look into that to see what's going on. So let's kind of do a quick save here. Just kind of show you procedures. Again, we'll just have the trains waiting here. Turn this off to here. And we're kind of at the raw state. So train 1, we're going to release first. So this will be green. Release the brake module. Train makes contact, sets this signal to red. Train is now emptying the upper right block and entering into the upper left. And then it's going to clear, activate the brake, and release the train behind it. Now this train is starting to move, hits this contact, changes this signal to red. Remember, a train is waiting here at the bottom at S3. And when it clears, so it cycles through. So now I have a blocking system that's actually going to prevent trains from whatever train is up here. The train behind it should not pass this signal set of blocks and create any kind of collisions. So, whoops, still on action. So that's, that's basically the procedure. Hopefully that was clear. I don't know. I don't really think I have to go through the rest of these event steps, but you can kind of see.
It's just repeating the same thing again.
Yes. So it's just repeating. There's a sequence to it. Now, the next thing, let me open up my notepad because I did make notes for this. We covered the sound functions, control listings. Okay. Now, there is one last thing that we're going to cover. We're going to move on to sort of the intermediate step, not really the advanced step, but we're going to do here. See if I can actually cover this because it gets a little confusing at one point. Sidings, dealing with sidings and routing. So right now we just kind of covered blocking. We're going to get into addressing when you have turnouts in your system, because there are sort of different ways of approaching things, and frankly it could get a little confusing, and wish me luck. Okay, so here we have sort of a set blocking example that I want to go through here. And we'll just go ahead and add things since you're sort of already familiar with how I'm doing this. I'm going to add a block here. I'm going to add my contact here. Okay, so these are going to be first two blocks here. There's various ways that we can set triggers. Okay, so let's say I have my train that's going around counterclockwise here. So in K1. I can set up conditions which are actually going to be more advanced, which I won't really cover too much, but I can set a condition that when a train makes contact here on the left, it can decide which way I want to switch this turnout. Okay. The other option, and generally one of the ones that this is the kind of option that I use with staging yards. But in simple setups like this, there may be ways where you actually want to do sort of a trailing control. And let me just set that up for you really quick, and we'll go through that procedure. This procedure here that I set up already, I'm gonna save that for next month because it's sort of an advanced feature, and I don't want to get bogged down with that. So let me just kind of edit the trackboard page. What I'm going to do in this instance is I'm actually going to put the contacts after the turnout, like this. And we won't worry about these brake modules or anything right now, because this is just sort of an example to kind of go through. What we will do now is we're going to actually program K2 first. Kind of see what we're doing here. So we're going to create my event here. Let's close this out. And I don't really need that because I don't use that. So what we're going to do is we're going to use K2 as our controlling icon or contact, right? So that's K2. You can see by the icon here that we discussed, it's set for an arrival contact. What I want to do is I want to actually set it for a departure contact. Right. Let's just kind of make sure when you reference this, it's a good idea to reference it. This is K2 space departure. Okay. And what we're going to do is, if you think about it, the contact in question is K2. It's the one on the siding. As soon as it goes off to gray, that means I've cleared this turnout. Right. And once it's clear, that means I can switch this turnout to any aspect that I want without having a derailment. Since I'm actually operating K2, I want it to say, well, there's a train on this line here. I want to actually switch that so that it's going to divert any train behind it to bypass it and not run into my train. So it's all sort of a safety procedure. So let's close that, and I will actually duplicate that procedure with K3. And this is going to be a departure. Now, if you were going to do this with circuit tracks, remember, you're reading the slider on a circuit track. You need to place this contact further up the line. So you can see why I like to use contact tracks. It just sort of gives me a cleaner way to deal with things. So we're going to, it's the opposite. I want that to turn green. Let's make sure I label this correctly. 3, departure. Okay, so here's how it functions. Obviously, I have my turnout to curve. My locomotive is going to make contact with the contact track. Once it clears that contact track, it diverts the train, the following train, to that. The same thing applies. It's going to go back and forth. Right? So this is a way you can do sort of, this is a good way to say it. It's look behind routing. So in other words, once the train clears, it looks behind it for control and allows the train behind it to pass it. So you're controlling what's going on behind the train rather than in front of it. Okay, and there's instances where we need to program in front, but again, that's advanced stuff, and I won't cover it in this section because that's going to be for next month where it's advanced. The blocking over here gets a little confusing because you do have sort of actually, no, let's kind of cover this. The instance that we have here, let's say the train is going straight, right? I can now actually create another event here. So let's say that both of my signals here are red and I got a train waiting here. Once I have K3 arrival, so we'll create a new event here, drag K3 under this, right? And this is actually going to be an arrival ticket because it just depends on when you want to trigger this release, and I'll make that clear in a second. So we're going to do K3 arrival. And because my train, we're dealing with the train on K3, right? I'm going to have it release the train on the secondary line.
Yeah, this looks suspiciously like our show layout routing.
Yeah. And so we're actually going to do the reverse now. So I could be, sometimes when you do this event process, you, as I mentioned in the article's got a really advanced one in this latest newsletter. Essentially what it is doing event programming can sometimes be, it's like a puzzle. You have an overall picture, but you can only solve the issues one bit at a time before you get to the overall picture. So this may become evident here because I'm kind of thinking ahead a little bit and I see where I have to make some adjustments. So here we are. These are arrival tags, and I'll show you how this all functions now. So now we've got a one single train on K1, right? And it's going to go straight. I have the two signals on S2 and the 3 that are red, and we don't really know if there's a train there or not. But once I hit an arrival, you see how it releases the train on the opposite line, because this train alone is really just going to stop at S3 anyways, because it's already red. Okay. And then when I have this train stop, but it clears, you want to be sure it clears the turnout, it sets the following train to divert to the siding because the train is still waiting at here. Now you can kind of see there's a problem. And the next train that comes in here is going to go to this, but it's programmed to bypass the siding because the light is still green, right? And if I left it at that and K2 makes contact, well, it's going to release the train on S3 and you're going to have a collision, right? So here's where you sort of have an option. And again, it gets a little fuzzy because you have to decide where you want things to occur. So I can do this one way. I can do this. So we were at this state, in the beginning state. I have a train going onto it. It's making arrival and releasing the train S2 so it clears, right? The train releases here, diverts the train, and the light is still green. So I can actually use that departure, edit events, open up the K3 departure. That means the train is fully on here, and I actually have it reset S2 to red. And we will do that now with K2D because it's the same, it's going to be the same function back and forth. So red. Okay, so this is option one, and we'll it'll clarify it in a minute here. So this is our initial state. I got a lane that's going to divert onto K2, make the activation, releases S3, right? Once it's past the turnout, it's going to change this, and it changed S3 back to red. So it's guaranteed to stop the following train. So as this goes back and forth, you can see it's going to cycle back and forth. It will always stop a train. And now you have a train that's basically adding another block, and your trains can go back and forth, left and right, because you're preventing and releasing trains based on what they're clearing. You know, obviously this isn't going to happen, but I kind of threw off the sequence. So, and it will reset eventually. So this is kind of like priming. This is option one. This is where we used K3, or we're using the departure tag to stop a train. When you have multiple lines, you can kind of do that. There's also another method, and let's go back into the edit board here. There's also another method that sometimes I use where I actually add another trigger past the turnout.
You just added a brake, not a trigger.
Oh yeah, sorry. Thanks, Rick. I'll add a trigger here, K4 now. Okay, and what I'll do, and this is good for staging yards sometimes because it avoids having to write all these extra tags. So what I'm going to do now is I'm actually going to go back into edit mode. I'll delete these stop sets. And remember, we're on the departure tags. Okay. And now what I'm going to do is I'm going to add K4. And you can do it either as an entry tag or an exit tag. It depends on where your sliders are being or what you want to do. So I might use this as an entry tag, basically because the distance between my signal and this contact are so far apart that I shouldn't have an interruption on the train. And what I'm going to do now is I'm actually going to set both signals to red. And how this will end up working now is, so we'll go back to the actual sequence of, hopefully you can envision it. And I know this is hard to picture because there's not actually a locomotive that I'm running. So you have to visualize it. K3 is going to make contact. It's going to release the train. Okay. And depending on the speed of the trains and the directions, this is where it gets, where you have to test it. The train is going to, you now have two motions. You have a train that's on K3 moving. You have a train that's on the S2 line that's going towards K4. And once K4 gets activated, it sets the light to red. And then this one is going to go green and divert the traffic. So it can all be in a matter of order. So let's say K2 now gets triggered and the train actually passes that contact, right? And you have a green light, which was the situation of the problem. But then K4 now will get triggered at some point, and both your signal lights will be red. So that's sort of kind of how you want to deal with this stuff, playing with it and just kind of triggering with it. But the trigger methods after sort of a sighting are sort of based on this logic. Again, if you follow along next month, where we do sort of like this pre-trigger where I was explaining K1, where it controls where a train goes, we're getting into advanced functions, and that's where we actually start dealing with something like, how do you navigate a staging yard? Okay, so I think that's basically the presentation.
Yeah.
I'm opening for questions. I'll stop sharing.
If you're following along and falling asleep in this webinar, just wait till the next one.
Yeah, get your coffee ready.
We just got a question from Norbert, adding a light signal. Oh, yeah. In the central station, some of them say SH0/1 or SH0/1 scale. I don't know what the word scale means. I never really figured it out. I forget. I'm wondering if they're the old style analog light signals, incandescent bulbs. I don't know. Yes, that is in there, and I don't know the answer to that, basically. I don't know. Curtis does.
No, I think some of those words, I never know if they're translation issues, and I'll just gloss over them and not really look at those. Did you answer some of these questions in the chat?
I've answered which chat?
Joe Piero, he's got okay, so we got a question. Can you run through the pros and cons of using the M84 to stop trains instead of signal wiring to stop sections? If you want to sort of, so the way I did it in the last examples was that the signal lights are more or less aesthetic, but in the way that I program, they're prototypically correct. When you use stop sections, physically the M84 functionality and stopping sections through the signal alone are the same. The trains generally come to an abrupt stop. Usually in the example that I use, it's when I'm programming something like a brake module, which is ideal for me visually for exposed stopping sections, because your trains will gradual stop, and then in which case, anytime you use the signal light alone, that is like an M84. It's just going to make the train stop. You get that jerking train where all your cars are just going to kind of run into the bumpers of each other. So physically, the actual functionality between an M84 and a signal light stop is exactly the same. However, you can program them in the events to occur at different points. So, again, the primary example is usually like if you have a train that's pushing, and you stop, if you set that signal to stop as soon as the train makes contact, it's just going to stop the locomotive because it's pushing the train when it got triggered by the caboose, for lack of a better word. Let's see.
Yeah, and basically the way we do it is we separate out the using an M84, M83 with a brake module. That way we can separate the signal aspect from the brake module itself. And one good example of that, it's Curtis came up with it, was you can have a light signal go green and have the train sit at the station and wait, because just because there's a green signal doesn't mean a train leaves in real life. It leaves on a schedule. So it gives you an added step of realism when you have a delay with a green light and then 5, 10, 20 seconds, the train takes off. It gives you a little bit of more realism.
Yeah, you got to give the engineer time to blow his nose, that kind of thing.
Yeah.
Okay, so one other comment we have is the circuit tracks. Okay, so let's say you have a locomotive, it's a rail car, it's got a trigger, it's got a slider at each end. This is another reason why I like to do things using contact tracks. Now, it doesn't mean that contact tracks don't have sort of like their kludges. Occasionally you get double triggers, which I've explained in previous methods. Circuit tracks are the same, or circuit tracks with trains with double, with two pickup shoes, you kind of run into the same problems. You're going to have to account for that and think about that, because what happens is if you have a train that has, a slider at each end, that first one's going to activate the trigger according to plan. And when that second one hits that contact, it's going to do the exact same thing. The funny thing is there's a way to nullify that, but to nullify that, you kind of have to use a contact track. But if you're using contact tracks, then why even bother with the circuit tracks? So
yeah, I mean, you can nullify it using a M84 technically. I mean, it definitely goes down a rabbit hole on how to fix that, and there are ways to do it. Basically, we like contact tracks because you don't have to worry about a slider, you don't have to worry about length of train because you have an exit trigger, and that's basically it. The pros are a little bit more than the cons, in our opinion.
Yeah, and Rick does touch on a point that I always like. When you're running contact tracks, if you're like me, not all my trains are the same length. So I'm going to vary the train length because, it's all about keeping myself from getting bored sometimes. So a contact track doesn't limit me to how long or short a train is, especially with a block. Let's say you had a train that expands 2 blocks. Well, you're still not hitting those exit triggers because the train is expanding a block. So that's the exit trigger that I explained in the last example. So yeah, there's definitely pluses to it. Circuit tracks, again, I think I've relegated them to sort of unique situations. Let's say you might be able to use them as sort of a directional control. It may be easier to use them as a directional control rather than contact tracks. Let me kind of open an example here. And this is sort of a topic that kind of come up. And what I'm going to talk about basically is using contact tracks as a directional controller. So this might be something that's good to cover. So let me create a quick example here. And yeah, I could probably use this example here. So let's edit trackboard page. So here, again, we're using contact tracks, not circuit tracks. Circuit tracks are great when you want to detect direction. But how do you do that if you're just using contact tracks? Well, let's put 2 contact tracks side by side. Oh, and yeah, again, sorry, we're actually kind of going off because this is an advanced function to some degree, but I can still show it to you. So let's get out of edit track mode. We go into edit mode. Basically what happens is that if my trigger is K2, right? And what I would do is once the train arrives at K2, you can sort of check the status. You see this question mark here? It's checking the status of K4. Okay, so we'll leave it at this. This basically, okay, so let's sort of just kind of show you this way. And this could be incorrect because I'm not thinking the complete logic. It's just an example right now. Essentially what's going to happen is that if my train starts to make contact with K2, and that means it's coming from the left side, right? If this is also yellow, right, that means there's, you know, it's the length of the train. It's covering both sides, or there's something occupying K4. If it's unoccupied like this, that means that my train is basically going in the left or right direction, right? Because it's impossible to be going from left to right and have occupancy on K4 already. Okay, does that make sense? Okay, so look at it this way. If this is occupied and my train is coming from left to right, it's literally impossible for the same train to make contact with K2 and already be occupying K4. So there's sort of a way that you can kind of make track detection. Now, the way this event step looks like, when you have a question mark, what it means is this condition has to match in order for the next step to occur. Okay, so if this was, let's say, gray, but K4 was yellow, then it's just going to stop this script. It's going to stop this event and nothing's going to happen. And you can actually do the same thing with turnouts, for instance. So we can do this, since this is actually part of a basic function. Let's actually go to the first example, and hopefully it doesn't confuse you, because, you know, it's kind of contradicting what I might have said earlier. But let's look at K1. Let's pull K1. Whoops. K1 is a control trigger, right? Let's get rid of that. I can actually now pull in a turnout. And in this edit mode, unless you're in advanced mode, which again we'll go back to, you have two different conditions. By default, everything is going to be in action. And what I mean by action is it's going to change this event to whatever this is set for. And the reason why I know it's an action is there's no question mark. However, I can use my contact tracks and create a question mark situation. And when I open this edit window, you see how now the condition setting is available. Okay, which I had to explore that. When you're not in an advanced mode, you're never going to have that available with a turnout or a signal light. It only occurs with contacts. So that's sort of, think of it as a preview for next month's article. And again, we get into it. I was kind of like confused by the fact that I saw the question mark and didn't see it here. But
yeah, it's just a teaser.
Sorry, go ahead.
It's just a teaser.
Yeah, it's just a teaser. Okay, so Rick, you kind of answered from the CS2 question.
Yeah,
that's good. All right. Anyway, so we're open up for questions. That's basically the full presentation. On
Couchman here says, do you find that contact tracks are being problematic in terms of dirty wheels, multiple entry and departure events as a single train? Yeah, that is something that happens. You should keep your wheels clean and your track clean, and it will significantly reduce any double triggers.
Yeah, and then we have the issues like straddling. So right now you can see that all my wheels are going to be on one complete track. But if you had a longer car and your wheels were out here, or it was longer than the base of your contact track, what's going to happen is the first set of wheels is going to trigger it. And then, you know, it's just like, again, this car is the wrong example. Your trailing wheels are going to trigger that event again. Yeah. So you have to be aware of the length of your contact tracks. You want them sort of to be as long as your longest car that you're going to operate. The clean wheels is definitely an issue. This particular train has double axles for each bogie, but if you have short cars that have single axles, then what happens is you may actually, because you have tension pulling the car, you might have something like the uneven table event where the tension actually pulls one wheel off the contact track. And rather than having like this distance to deal with, you'll have this distance to the next bogey on the previous car. And that can cause a weird tracking. I had an issue with a VT11-1 because I think it had a single axle, and for some reason that was the only train that was causing a derailment because it was lifting the wheel set off my contact track that I had. So there's ways around that. We get into advanced stuff again, but just kind of let you know that it's out there.
And here's one of our most typical questions. What do we recommend for cleaning wheels and track? Well,
go ahead.
Go ahead. Okay, I'll do it again.
Go ahead.
You've been talking enough. We recommend smoke fluid. Smoke fluid is just kerosene. Go down to the hardware store, get a jug of kerosene. It's the same as smoke fluid, and it is also a track cleaner. If you use alcohol, it gets the track too clean. And it's not conductive from the wheels to the rails. So kerosene seems to work best. And even for LGB track clean or smoke fluid, it says smoke fluid and cleaner. So it just doesn't say that on the other brands, but yeah, we use kerosene and it works great.
Yeah, some people like to use naphtha, but I think cost per quart is just cheaper to buy kerosene. Citronella. Somebody uses it. Probably smells. You got the nicest smelling layout.
I wouldn't necessarily use an oil. I think that would be too heavy of an oil. Plus, it has the added benefit of other chemicals in it for the citronella. You say it worked. Okay. You know what? You find what you like best and use it. One thing that we highly recommend is do not use steel wool ever. Don't get it anywhere near your track or your trains. So.
And, I know I think we have a friend of ours who let me use, I don't know what they call them. They're like sanding stones or they're sort of soft abrasives.
Yeah, the little, they're just, the track cleaning erasers. And those work well. Again, we like kerosene because dual purpose.
And kerosene, yeah, exactly. You can use kerosene for smoke fluid because smoke fluid is primarily kerosene.
Yeah. Basically you can use whatever you want. One thing we say is don't use steel wool. We use kerosene.
Yeah. I'm not familiar what inox is or if that's how you pronounce it. So, but that's a recommendation from one of our viewers. Okay. Anything else? Now I did touch off with programming events with locomotives. There are a lot of guys will like to want to use locomotives for speed control around the layout, or like they want a whistle to go off on a station area. There is an inherent problem with that because I don't know if I need a visual example for it.
No. Basically, you have a trigger on a layout that activates a function on a locomotive where that's great, but every time any car or locomotive goes over that trigger, it's going to activate that same locomotive anywhere.
Yeah, and wording it a different way in case it helps is that let's say you programmed a locomotive 1 to be triggered by K1. That's great, but what happens when locomotive 2 hits K1? The trigger is still K1 and it's going to make locomotive 1 blow its whistle wherever it is on the layout. So programming events, especially locomotive events, I think for the most part and without any advanced sort of developments in the operation of the CS is it's ideal to keep those as manually controlled, and mostly what we've just talked about is track control automation. So we're controlling the track to control what the locomotive is doing, whether it's rerouting on a turnout or stopping at a brake module or a signal light, but we are not actually controlling the speed of the locomotive in that sense. So all right, 10 minutes to go. Anything else you guys are curious about? We can open up the field for any issues you might.
If anyone wants to talk, raise your hand. We'll allow you to talk. If not, we can just stare at each other.
All right. Well, let's see. Do you think a CS3 will ever track local location? Well, that's definitely a good question. I know there's a way to do something like that. But me knowing and me relaying that fact to Germany, problematic at best. There's translation issues, there's complexity issues. But I can be helpful. They may not be aware that I've kind of said that, yeah, you can track locomotives. It's just not implemented in any ways. I've actually been sort of toying around with that feature, and but it's event programming that I won't even get into. It's way complex. I mean, you can turn one script into 50 because of the control functions that you want. So yeah, the only way to do it, think of it this way: the CS3 is one step of actually full computer control. And really, I think it is, because a computer program has sort of been designed to sort of set up pre-planned routing. Well, actually, that's not even true. A computer control software is allowed to variables of routing as well as identifying blocks where your trains are. So that's another reason why you need to support blocking definition of only allowing one train per block.
We got a question on Facebook here. People wonder how to change an address, a locomotive address with the CS3. If it's MFX, you don't need to change the address. It gets assigned a unique tag, so you never need to change the address. There is an default address in there, but it's more of an identification thing. In the configuration screen, are you going to look for that, Curtis? Or
no, I actually want to. I'm sorry, I kind of shared the screen too early. I actually want to kind of go back to one thing that we didn't cover in some of the event setup windows.
So if you want to know how to change an address in a locomotive, a default address of an MFX locomotive, you have to get into the CVs. And if you want, I can show you that. I've also covered that in the previous webinar.
I can, you know what? I can probably do it if you want to like talk me through it, and I can just.
Well, you need the locomotive on the track.
All right, so let me.
That address you see here.
So let me just add a locomotive from the database.
It won't work.
Oh, because we're changing an MFX locomotive or a program?
Well, a default address for a minute. Right here, if it's from the database, you just change it right there.
Well, actually, no, this is a control. This won't actually change it from here. I thought that would just.
If it's an FX decoder, yes.
Okay.
I believe so.
All right. Well, anyways, so let me get back.
It won't work because you don't have an MFX.
Yeah, let me get back to a point that I was trying to make when I set up this pre-sharing window. So let me add a couple locomotives. There's 37450. 50. Default, that one's easy to find. And I'm going to add another locomotive. Let's click OK here. Add one more. Give me a number. Give me a number really quick.
37080.
3708 what?
80. 37080.
Right there. Okay, I had to type it in here. VR10. Okay, so what's nice when you let's say you actually do program an event here, folks. So let's program a locomotive event really quick. So this here, It doesn't have to be elaborate. Just want to show a locomotive control. What's kind of cool about this, when you have an event and you set it up to run on a specific locomotive, let's say you want to change out locomotives. Well, you can just go to this icon here and it will actually give you a listing of all the locomotives in your inventory. And now you can change that event to operate using a different locomotive. So just wanted to get that out there because we didn't really cover it the first time out. Again, it has to be in your inventory and it will give you a list of locomotives that you can select from. All right, I just wanted to get that out of the way really quick. I want to control Essential Station 2 from the PC. When I open the application on the PC, I have to open a lot of panels for all the locomotives. When I shut down the CS2, all the control panels on the PC are closed. Next time I have to open again, all the control panels are that could just be a default setting for the CS2. It doesn't really retain, the software itself isn't going to retain your Windows setup. So by default, it's probably just going to have those windows closed. Because remember, you're opening panels on the PC. You're not actually opening a panel on the CS2 itself. Okay. Is there a trick to make uncoupler track work more effectively used remotely? It maybe works 25% of the time. I think the issue with uncoupler tracks is the duration of while it's on, if that's what you're concerned with. As long as it's up, then you kind of have to make your locomotive sort of, I think in some ways you want to, if it doesn't just uncouple, you want to maybe like move the locomotive back towards the train it needs to uncouple from, and then move it forward while it's still on the uncoupler track. Hopefully that answers that question.
Yeah, hopefully that helps.
If you're using a circuit track in an event, which when trip turns a turnout, can you turn this event off when you don't want it to work? Again, Sean, you can do that. It gets a little tricky though. One method that I've used, and hopefully you understand, is that maybe I would wire. You could, like one instance, I have wired a circuit track through an S88, I believe is what I did. No, I wired a contact track through an M84 or a K84. And what I've done was, if I didn't want it to read that contact track, I'd turn off that output for that K84. And hopefully that made sense to you.
And then you put that into a script and when you want it to trigger or not, depending on the conditions of the layout.
Right. And then you also have to remember at what point do you want to turn that contact track into being readable, which means you're turning off or turning back on its K84 output control. So there's ways around it. It's just one of the examples that we've done or used. Oops. Can you include changing turnouts in a loc event? Yes, you can.
Well, it's not really a loc event. It's more of a...
Well, I know it's an event in the event stream. It's just a step in the event stream. But the thing is, you got to be careful when you're going to, how that activates. It's one of those things that test it. You can certainly drag a turnout change on an event step script for a locomotive. It's just, finding the way to do it. Is it worth the money to replace the CS2 with the CS3? I can't answer the value for you, but there are definitely benefits to the CS3. The response time for the CS3, it does have a faster processor, so you're going to get quicker reactions for when events might occur. It's all basically the same. Let alone the boot time is faster, the shutdown time is faster. I'm not standing around waiting for the CS2 to shut down. Depending on your version of your CS2, you're not going to lose value because you can use it as a
auxiliary device.
Or an auxiliary control, and the newer ones you can actually use as a booster control. It's sort of a biased question. We might always promote the CS3, but I think overall in the timeline that we've had the CS3, Definitely, I like using it more than the CS2 now. It's easier to program. Definitely easier to program. You have to get used to where the windows are, but once you do, there's just simplicity about it that wasn't done in the CS2. And frankly, the CS2 was the development stage for the CS3, so they've learned a lot about how it operates and how to work with it. So, all right. Well, listen, we have come to the end of our program. We again appreciate you guys joining us.
Are there any more questions before we sign off?
We can take any pressing questions if you have one really quick. But in lieu of that, hope you guys have a great holiday. Oh, got a couple of hands raised. Well, one hand raised.
Yeah, we got Ray asking about the default address. He's talking about Markland Motorola decoders. So it's in the you can either do that in the CVs of their FX decoders if they're no dip switches. If not, you use the dip switches, and you can change the CVs and program it on the programming track of the central station. That's where it takes it. That's one use of the programming track, is for modifying FX decoders. So.
Okay, do we want to, should we, Avi wants, I guess he wants something to say, so let's put him on speaker. Avi, can you hear us? Your microphone is muted out, so if you're trying to say anything, you need to unmute your mic.
Sorry?
There you go. You have a question, or you just kind of inadvertently raised your hand?
Yeah, I just asked my question. Thank you very much for answering me.
All right, Avi. Okay, thanks.
I'm calling from Israel, by the way.
Oh, wow, great.
What time is it?
Thanks for visiting.
Now?
Yeah.
11 p.m.
Wow.
Okay.
All right. Well, I guess you want to get some sleep.
Well, good night.
It's okay. It's okay. I enjoy staying with you.
All right. Thank you. Thanks for joining us.
Yeah.
Now we'll go on to Sean. All right. Take care.
Okay.
All right. So, Sean, you had a question for us?
Unmute your microphone, Sean.
Okay. My question is, suppose you want to just set a series of switches because you're going to run a loc in a particular, sequence.
Yeah.
You set it as an event, but you don't use any contact to a circuit tracks?
It has to have a contact.
No, it doesn't. Not if you want to. If you want to control that manually, by default, anytime you open up an event script, it's going to be set for manual control.
You'd have to push play. Yes.
Yeah. So the thing is how you want to trigger it. It gets a little sketchy because the thing is, and only one way to activate your events is you have to have your event windows open. That's the listing of all your events. You can optimize that by grouping those events so that you only view your manual events. The other way that you could probably do that, and it's a weird way to do it, but it's effective. You can kind of create false contacts that aren't actually attached to the track.
Here, let me share my screen.
Drag them on the layout page. Go ahead.
Wait a second. I don't think I'm ready. Because that's what I did for the Christmas tree, remember?
No, okay, yeah. So once you get set up, go ahead and share your screen.
If I can find it.
Dun, 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 dun.
Here, back to the beginning.
Dun, 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 dun.
There it is. Okay, so this is the content. This is the
Event
article list, and I have a M84 controlling my little Christmas tree here next to me. My events for the tree on is basically, I'm sorry, that's tree off. For tree on is basically turn all the contacts on, because each contact controls 2 lights on the Christmas tree. Okay, so I wanted this to activate, and here I can shut it all off if I do it from the event screen. And this is what Curtis was talking about. You don't need a contact to do this. I can do it from the event screen. but I didn't want to do it from the event screen. I wanted to do it from the control board. I'm sorry, the layout screen. So you have to create a contact on your board to activate that event from your track board, control board here. So that's why I said, yes, you need it. So if you wanted it to activate from your layout, and you can, this can be anything, any kind of contact in there. And you would see all the turnouts change, whatever you have it programmed for. Myself, I just have it programmed for the M84. Oops, wait a second. Let me pull it down a little bit more. And I should probably sort these. I'm not going to go through that, but I think I can. There, you see it, it changes all my M84 contacts on my event screen. So the answer is yes and no. For convenience, you need a contact if it's on your board. Just to do it at any point, you can do it from your event screen.
But where is your icon coming from?
Which icon? This icon?
Yes, that icon.
That you can select the icon when you set up the trigger, or when you set up the contact.
Okay, I like that because I could have a series on. I have 3 levels, so on each level, I could set the switches for a particular train that I want.
Yes, yes, yes. So yeah, there's a variety of contacts you can choose from.
Okay, so we do have, are we done? Thanks, Sean. We do have a question about, well, one, do you or I speak Spanish? Unfortunately, no.
No, we only know the bad words.
Yeah. And then also, I guess you're having trouble taking advantage of track. The part number is a 24995 contact track.
Yeah.
I would suggest at this point, maybe send us an email, because we are going to have to troubleshoot and figure out where the error may be occurring.
That's the contact track that comes.
Yeah, but it's a pair of tracks, right?
Right. But if he's putting regular tracking between it, the contact is not working.
Well, yeah, that's the issue. I just don't know what issue it is. You got to remember that when you put any tracks between those pairs, those rails have to be cut. But let's take that offline. Send us an email on that one, and we can answer you. Anyways, again, I think thanks a lot, guys. Thanks for attending. We're at the end of our session. Appreciate you guys joining us.
And you can always email us or call us if you have any more questions, and we'll be glad to answer them.
And check your email, because again, we do have the new
newsletter went out today.
Thanks, guys. Again, we're happy to be here and help you guys out when you have questions. All right. Have a Merry Christmas or Happy Holidays, or whatever holiday you kind of
be safe.
Thanks. And yeah, be safe, and we'll see you again next month. We're going to cover advanced programming steps. Maybe we'll get into a little bit of how to set up a staging yard, and look forward to seeing you, or at least look forward to you seeing us.
Yeah, and look what I did, Curtis.
Yeah, there's that Christmas tree again. Too bad I burned mine up. I got to fix it again. So, all right. Cheers, folks.
Bye, everybody.
Also, Happy New Year's. So,
yes.
Take care.
All right. Bye.
Bye.